Good evening, folks. How are you? I'm going to let this thing take just a couple of minutes to make sure we are streaming and live and everything is good. I am watching the comments up on Facebook and YouTube. I'm going to try and also monitor Discord a little bit. And so I'm gonna have a bit more to watch than usual here tonight. So I'm probably gonna do it poorly. Well, that's life. Tonight we're gonna talk a little bit about USB host. And some of you are gonna be like, I don't understand what you're talking about. This is gonna be a geeky conversation. But some of you are very aware of what I'm talking about. And there is discussion and motion on the technical community whether that's the Circuit Python group or the Teeny USB group, Adafruit group in general, as well as the folks at Makers Making Change and elsewhere. So I want to kind of give my my 2 cents here. I've already written up something on a bug in GitHub for Circuit Python, and I'm sure they listen to it. They're very good about that. But they're talking about how to design. Hey, Chris, how are you? Chris Young's here. They're talking about how to design a USB host interface for Circuit Python. And we're going to use that. If that exists, we will absolutely use that. I'm going to show some examples here today of ways that we do this today. Some things that we found didn't work at all, and kind of show those before people repeat those mistakes. I want to get them out there. And then maybe give some wish lists or at least some feedback on how we'd like things to work. I have an extra camera running. Of course I do. Well, we're gonna live with it. If my USB doesn't have enough power for all these cameras, then I'll start unplugging things. But for right now, we're good. So let's get started. We'll talk a little bit about USB host, what it is that we're talking about, and why we care. So when we do a lot of the AT devices that we use, that we make, pretend to be USB HID devices. So we'll have a joystick. We'll have one of these joysticks right here. And we'll turn it into something that looks like a mouse to the computer. Or we'll have the Xbox adaptive controller, and we'll make some custom tank control, and we'll make it look like a gamepad. So when we do something like that kind of USB work, that's called USB device work. So we're taking a custom device that we make, and we're making it act as if it was a keyboard. We're making it act as if it was a mouse. That's also true when we're doing things like switch control for the iPhone, right? So we are making the device that we're making look like a keyboard because the iPhone will treat a Bluetooth keyboard as if it is a switch. A lot of the things we make have to do with tricking the computer into thinking the thing we made is an HID device. And so really, HID stands for human interface device. It's a keyboard, a mouse, a gamepad. There are a couple other things like media control devices. Joysticks and gamepads are technically different devices. So there's a few things like that. But these are all devices that are meant to take motion from a person, a human, and convert that into things that the computer can understand. As you would understand, that is a big deal for us because it's kind of the basis for a lot of the things we make. The difference is the human we're dealing with in AT makers and a lot of AT work need different inputs than your standard, I can use a mouse just fine, or I can type with both hands and things like that. So that's USB device work. USB host is different. USB host is where I have a device and I want to use a mouse to control that device. Okay, I want to use a joystick to control that device, a standard joystick or keyboard or whatever it is, a mouse. I want to plug that into my device and use it as an input. Kind of the opposite of what we're trying to do. In our case, the biggest place that we've used USB host has been in the IntelliKeys keyboard. So I want to walk you through this. This will kind of explain a little bit what we're doing and how we're using this and why we're going to care about this. Okay. And feel free to give me any questions. I think I can see Facebook and YouTube. I don't think I can see the Facebook group questions yet, but I can fix that. I can go here and maybe. Let's see. Maybe not. Groups, AT makers. Okay, so yes, I can now see those two. So I think I can see all the comments from everywhere somehow. So feel free to type whatever you'd like. Okay. Where's my StreamYard? There it is. Okay. So let me switch to the overhead here for a second. So this is the IntelliKeys keyboard. Now, lots and lots of you know what this is. Alyssa Wern helped save it from the wrecking ball. We got the software for this open sourced. It is a programmable keyboard that will that allows you to define, draw out on a piece of paper where the keys are going to be, set that up in software so that when, like right now, when I type, I don't know if you can be able to see it. If I type an F, it's going to show up as an F in my as a regular keyboard. So this device came out in the 90s. I want to say early 90s. So there was there was a PS2 version of this. I think the USB version of it came out somewhere in the mid 90s. It is still the only way a lot of people with cerebral palsy can type effectively. It is the most effective way for many people with cerebral palsy to type. And a lot of that has to do with the physical design of this. You'll see I've got a key guard on here. I don't know if you can really see that very well or not, but there's a piece of plastic holding my hand off of the keys. So I don't know if I can get that to, there you go, focus. So I can lay my hand on top, and when I work my finger in and hit the S key, I get that button without having all the other keys here being pressed. And I think fundamentally, this is why this is still so popular with people who have trouble with fine motor control. We were able to salvage this in two ways. First thing we did was we got the drivers open sourced, and we were able to get one release out for Windows 10 and got it signed so that it would work and everything. And then the other thing that we created was we created a dongle. Let me show this here. So we created this device right here, which basically lets you take the keyboard on the black side here, read it into this device, and on the other side, it looks like a standard USB keyboard, a standard HID keyboard. There's nothing fancy about it. It's got, the QWERTY keys, and it also shows up as a mouse, a keyboard and a mouse together. Because if you look at the actual layout over here, and I'll try not to refocus all the time, but if you look at the layout, it's got a set of arrow keys over here, which are mouse movements. So if I hit up and to the left, my mouse is going to move up and to the left, etc., and I can click, double click, right click, that kind of stuff. So what this little device down here does is it turns this bizarre non-standard USB device into two standard USB devices, a keyboard and a mouse. The way it does that is that it has two separate, let me turn off my camera here. It has two separate devices. It has a microcontroller on the left, which is nonstop reading the keyboard. and one on the right, which is nonstop sending keyboard events to the PC. These two communicate with each other over a serial connection, a UART connection, and they send messages back and forth to make this work. This one over here is running what's called USB host. It is hosting the keyboard. This one over here is acting like a USB device. So when we talk about USB device, that's this green guy. USB host is this pinkish purple guy over here. Okay. This is what we're talking about so much right now in the technical world is USB host. How can we do this better? And there are a lot of devices right now that can do both. There are several devices right now that can do both USB device and USB host at the same time without having to do two separate microcontrollers with double the cost and all the soldering necessary and things like that. So we're trying to improve that. We're trying to make it so that this is something that is easier to get away with. Now, I thought that we had a slightly better solution a little while ago. I made this one, which is really cool. So this is a QT Py M0, and you'll notice that on the other side there's a QT Py M0. And these are really neat because they're surface mount castellated pads, which means that we can solder them onto one side without having them interfere with the others. I thought this is great. It's going to cut my cost. It's going to cut the amount. It cuts the amount of soldering in half, cuts the space down. But there were some problems. The biggest problem, I don't know if I'll be able to show you, is this little diode right here. So this little diode means that we cannot take the 5-volt input and drive the USB host. So on this one, it does work because I replaced the diode with a little piece of wire right here. And this is not a solution that I want to use long term. So I asked Adafruit about it, and Limor was gracious enough that she now puts a jumper on the back of a lot of these boards so that you can just dab a piece of solder and get rid of that diode. It's great. It's a really good solution. The problem is that all of the other chips that are out there right now don't run the software that we're using here. So this is using a SAMD21 host software, which I can show you here. So this is the USB host library ported to the SAMD microprocessor by GD Sports on GitHub, and this is what it's based on. Before I ever worked with GD is the only name I know. Before I ever worked on this project, this had already been released, which is an IntelliKeys USB host library for SAMD. That's what UHSLS is, driver. And basically, if you look, they had seen that we needed a solution. They had done a lot of reverse engineering from what we had posted. And they basically had this reading the USB, the non-standard USB protocol and reading it into a SAMD21, which is kind of exactly what we needed. It was great. It was a really great place to start because we could read this non-standard protocol and get it into the device. We then went and made the communication between the two boards, and we made the software that did the mapping from the non-standard HID to the standard HID. And we wrote that in Circuit Python. So if you go here to the iKeys adapters on the atmakers.org, you'll see that there is Python that will actually reads that non-standard stuff over the serial port, converts it to keystrokes and sends them. In addition, there is logic here that will read that driver library, read the events from that driver library. And as presses of the cell membrane on this paper are sent, it basically converts them into a form that can be sent over to Python to be able to convert it. So this is what we're currently using for USB host. And you'll notice that we're using two different languages, two different libraries. It is handy that we're able to use two of the same chips, but we are having to use two chips for our solution. And I'm not even complaining that much about this. But the other thing that we have to do that's kind of ugly is we're constantly having to buy adapters, right? Because all these boards come with either a USB-C uh, or a micro B like this, where we've got to either get a USB micro B to A, or we've got to like find this really weird cable. This is a truly strange cable. It is a micro B to full size B cable that we were able to find on AliExpress and use. So we don't really have a USB host port anywhere in this solution, which it doesn't seem like it should be that big of a deal. But like this weird cable is $6.95, and that kind of doubles the cost of making this board. So this is kind of hacked together at this point. It does absolutely work, right? So I don't want anybody to think we don't have a working solution. I know that the IntelliKey solution works really well. I also know it is limited right now by the hardware we're using and by the USB host solutions that we're using. So I am hoping that as Scott Shawcroft and Dan Halbert and the CircuitPython crew start looking at USB host, and as the hardware that we're looking at starts getting these secondary USB ports, we're going to find a better solution. Okay. So let's talk a little bit about what we've learned that doesn't work and what we've learned that does, so that we can make sure that the thing that does work gets supported in the new libraries and stuff. So let me see. I'm going to see if I can do any better than Scott did with his tablet the other day. By the way, this is all in response to Scott Shawcroft came out with a live stream on Friday. I don't know, 3 hours, 2.5 hour live stream on Friday that walked through what he was thinking about. He's the lead of the CircuitPython group, and what he was thinking about doing in terms of USB host. So this is a basic, I drew up a quick picture here of how our current setup works, or at least how it worked when we started. Okay. Here's our PC. It's getting HID keyboard commands from a Trinket microprocessor 1. And that is talking over a serial UART connection to the microprocessor 2, which is another Trinket. And that is talking the custom HID to the IntelliKeys keyboard. When we started, the way this worked is that this Trinket would constantly read the IntelliKeys keyboard and look for changes in the membrane events saying, cell 3, 4, so cell column 3, row 4 was just pressed. And basically the IntelliKeys is a 24 by 24 grid of cells. I know it's rectangular, but they're just not square cells. But it's 24 by 24 grid. It would basically, every time it saw a key press, it would send that event to this Trinket. This Trinket would then send that request to this Trinket over UART. This guy would look up, okay, what should 3.4 be? That's going to send a Q, and therefore it would send a Q. It had a bunch of logic in here to make sure that, like, if 3.4 and 3.5 were both pressed and both of those covered the Q, it would only send the Q once, kind of stuff, right? But originally, every time the keyboard was pressed, any cell on the keyboard was pressed, that would issue an event between the two microcontrollers, and that would then trigger a press or a release or things like that. And as good as this looks on paper, it totally doesn't work. We had two big problems with this. The first is these two things were running at very different speeds. This one's running Arduino. This one's running CircuitPython. So Arduino is about 12 times faster, I think, ballpark, maybe 10 times faster. And so it could send far more requests than this guy could process. In addition, this guy was slowed by the PC. In other words, the PC had to read that queue event, process it, and get back as well. And this didn't work. And the big problem with this is that if this reading side gets faster than this writing side, this thing will queue up and you'll end up dropping events. And the problem is you drop release events. So you'd hit the press and the release of 3.4 would come in and it would queue up and it would get dropped. And it would either get dropped in a queue here or here, but one way or the other, it would never send the release event. And you'd have a queue that just kept typing and typing and typing forever because the release was never seen. So this doesn't work. And so we restructured this. We rethought it. And what we did instead, which makes a lot more sense, we had the IntelliKeys the same way. We had it going into the same, and the hardware is the same, right? So this is the second microprocessor, and this is the custom HID. This guy was still saying, okay, I got a press of 3.4, but this guy didn't send an event at all. So what this guy did is he actually just stored a sorted list. And so this would be, let's just say 3.4. It actually gets converted into an integer. And then if there's another press of 3.5, it would add this to the list of what's currently pressed, right? And then the second microcontroller would pull. And it would say, give me all the things that are currently pressed. And so this microcontroller just packs up this list and sends them. This one then does logic to say, okay, which cells went up, which ones went down, depending, comparing it to the last event that I got, and then send and release the presses and releases that I need to get what I think should be currently down to match what's on the other side. So this guy then sends press Q to the PC. Okay. So this buffered architecture. Sorry, you guys can't see this, can you? I'm so sorry. I am no better than Scott with his tablet. All right. So this buffer that's smarter and says, I'm just going to update this internal state of what's currently pressed and send it whenever it's requested, means that it is possible for a press 1.2 release 1.2 to happen and this guy to never see it. It's possible that a press and release can happen and this guy will never see it. But what's not really possible is that a press can happen without a release. And it turns out nobody cares if a release happens and there's no press. Nobody cares. So what this does is it means that we don't have to do the synchronization stuff of trying to keep these guys going at the same speed and caring. Chris says you're writing off the bottom of the screen. I know. I just learned that. So I should read my comments more often. I'm sorry. But by doing this in a smarter buffer, it allows us to make this a much simpler process, right? So this guy's job is just read the keyboard, keep a tab of which cells are currently pressed and which ones are released. Whenever it's asked, send the list. This guy's job is take that new list. I can show you here. There's a mapping here. So just look into this mapping and say, which cell do I send if 3,4 is down? And basically that's what it does. It looks for changes, and it either sends the keys that are needed, or like here. So it reads the results. It makes sure that the overlay hasn't changed. That just means if they change the piece of paper on it. And then it goes through all the cells that are down and figures out what action it should take. Should it send a keystroke? Should it move a mouse? Should it change the shift control or alt keys? And then it presses the keystrokes and releases them for whatever keys are currently down. Now, there are some things we do here that keyboard purists are going to hate. We are sending one keystroke at a time on purpose, because if you looked at how the IntelliKeys worked, it is meant for moving your finger into a cell and pressing one at a time. That's the whole purpose of this device. It doesn't, allowing 7 keys to be pressed at a time isn't necessary here. We can certainly do that, right? This architecture doesn't require that we send one keystroke at a time. It's just that that's what this logic does. Okay. So that's what we've done on our most popular USB host tool. Okay. There are lots of other reasons for wanting this. So let me show you again this guy. So the reason I did this device, okay, wasn't to make a smaller IntelliKeys adapter. That problem's kind of solved. There are some issues with it. We're running MicroPython or MicroCircuitPython on a Trinket M0 is actually kind of challenging. There's not quite enough memory for it. So we have a very custom build of CircuitPython running on it, but that's not the issue. The reason I did this one was I had a request for a filter. And so what they wanted the filter to do was to allow you to change a mouse. So we ran a USB-C cord to one side of this, and then I actually bought a USB-C mouse, which I found one. But if not, I could certainly use an adapter to plug in a mouse. And in this case, it's very similar, but it's not doing keystrokes, right? So let me kind of walk through. Let me just, I'm not entirely sure how to explain this. Let me just show you. So what they wanted was the ability to take my mouse inputs, which are very variable input. I can move at any angle and any amount. And they wanted to be able to say things like only move orthographically, only move horizontal or vertical. And if I'm moving at an angle, choose one, so that the mouse would only move horizontally or vertically. And you say, why would you want to do that? Well, if you've got somebody with an unsteady hand, or who can't, who just finds it easier to move left and then move up, just because of whatever their challenges, their disability is. Another one wanted an averaging, so that if you have a hand that's shaking or moving, right, you want to average over time how much you move the mouse. That was actually hugely successful. That really did work at getting rid of a tremor that we put this in the field in. What this requires is nothing more than a device that has a mouse on one side and pretends to be a mouse on the other, but does some logic in between. And there's actually a lot of logic we can do in between. We can remap keyboards. We can add filtering to mice. We can also change what each thing looks like. So we can say that this mouse, we want it to go into this Xbox adaptive controller, but this only takes joysticks. Okay, let's make this mouse look like a joystick, right? We've got the buttons, and we're just going to say up and down and left and right moves the joystick. We can do that with this little device, right? But right now, using this device kind of sucks. What they're talking about doing in CircuitPython would be hugely helppful, because in one device, without all the synchronization issues of communication over UART, I know I'm talking with my hands again. I'm sorry. We would be able to do that. I'll show you very briefly what I think we would want this to look like. Maybe. So I'm opening up Eagle here. You guys can't see anything. Um, I'm trying to open up Eagle here. So here's a device that is like the simplest thing I could think of. This would go on top of a QT Py RP2040, and down here at the bottom, this is actually a USB-A female port. So that would let me take something that looks just like this, stick literally a USB-A female. In other words, it would take a device, it would add a port that looks like this, that your mouse can just plug into, to a device that looks like this, okay, on the back. And if we had the ability to use the RP2040 secondary port, that would just work. We have another one of these that's a I think I called it a host drinky. It probably isn't the right word, but yeah. So this is basically the same idea. It would take a KB2040, which is a RP2040 based device, give it a USB host key right here. So you'll stick it in, have a USB port on the back. It's a super simple device, but it would let you, for very little money, take a device like, let me show you this KB2040. If you take one of these $10 devices or $9 devices, solder it on there, it would take absolutely no effort to then solder on the USB-A device, and you would have exactly what we want. We want a USB device like this. On the other end, we would have the port that you could plug into. You wouldn't have to worry about the communication between the boards. You'd simply have one microcontroller doing both. The thing to think about on that is that even if we only have one microcontroller, we kind of have to have the same kind of buffer architecture where the reading side, whether that's a task or a second core or the tiny USB task, has to update what is currently being pressed. And then the side that sends the device commands out has to read those things. We don't want to try and sync up every one of the incoming HID requests with an outgoing HID request because they won't sync up. In the case of the mouse, what we did with that was we would read all of the mouse movements, just keep an aggregate increase and decrease of the X and Y coordinates. And when the call came in for it, we would send that many plus and minus, send that many things that it needed to go. The slower that it was requested, the more tremors it reduced. It's kind of an elegant way to do that. We'd still have to have that approach inside of the one core. So I guess that's probably the most important thing to make sure that Scott and those folks get is that when you're doing a filter like this, you've got to have some ability to not walk in lockstep between the device and the host. We've got to have a way to decouple those in time. Read the events from the host side, and then when we're ready, send the updated commands on the device side. So I think that's the core of the USB host stuff. I stuck to about a half an hour, I think. I'm not sure. Probably shorter than most of my streams, though. Way shorter than Scott's. So I think that's probably the most important thing I wanted to get to him. If you have any questions, let me know. Chris says, is Adafruit going to make a device with two USB-C connectors? I don't know. I hope not. I hope they make a USB-C connector and a USB-A female connector. If they did the two USBs, that would be fine. Right now there are very few things that have built-in native HID devices with a USB plug on them. There are some, but like when I went to find the USB-C mouse, it was very hard. So I would much rather see a USB-A. I'd love to see them make the device I just showed as a Featherwing or as a BFF, right? They can make it. I don't want to make it. I have no effective way to distribute these things right now, which we can talk about in a minute. We can make ones that have two on it. The real problem we have with these right now is that all of the better cutie pies, the RP2040, the ESP32, the ESP32S2, S3, and I don't think there's an NRF52, but if there is, that would also have they have devices on the back. And so that means that you can't do back to back like this because you've got to have a cutout for the devices. So it just makes them bigger. The KB2040, one of the nice things about that is that it has nothing on the back, right? So it's very easy. You could put these back to back if you wanted to. There's no need to put cutouts on the Eagle file. I will tell you, I was just working. I just sent in an order to this one. I was just putting in an order to PCBWay. It should be here later in the week. That for a device that looks a lot like what we're using for the IntelliKeys. Chris, okay, so gotcha. So if this ever opens, I have too many things open right now. I'm sorry. This board is very, very similar to the one you saw me show. Here it is. That one. So here, let me show you what it looks like. So this board is meant to replace the board I showed, the IntelliKeys adapter. It's got a trinket on one side and a QT Py RP2040 on the other. I had to put this big cutout to make room for the items that were on the chips were on the back of the board. The only reason I bothered making this, I would much rather just wait for us to have a good host device. But I went ahead and made this because if I did this, I would run Arduino in the host side here on the trinket, and I would run the CircuitPython side over here on the RP2040 because I'd have enough memory to host all of the overlays that come with the IntelliKeys, where right now we only have enough RAM to host 2 of the 8 IntelliKeys overlays. So this would allow me to do that. I could use the header pins over here instead, but it's twice the amount of soldering. And I for the kids up in Gainesville who are putting these together, if I can reduce that, I want to. So this is on the way from Fab House. Hopefully I'll get it later this week and get some put together and get them shipped out. It still relies on the weird cables, which I still don't like, but it is what it is. So this is where we are, which is not in a great place, right? That's why I'm excited to hear about what Scott and the others are thinking about in terms of the USB host support. There are obviously lots of other good uses for USB host support. Actually, tons of them. It's great for programming chips. You can program chips from chips, right? I think there's a comment that they could have CircuitPython, load CircuitPython on another device. You can do that. You can do something like if I wanted to make a controller for a drone that took a mouse or a gamepad, it would just work, right? If I wanted to control whatever it is with a standard gamepad or like a DualShock PS4 device, I could just add that ability into any device that we make. So it's big on a lot of different levels. But for us, I think the adapters are going to be the things that we use immediately and that we've already shown can make a big difference in people's lives, and that we want to make sure that they support. So hopefully this helps. And I think that's about it. So unless I see questions, let me double check. I have that one screen I can't see here. I don't see any comments. Good enough. So anybody has questions? I have one other topic that we want to talk about, but all I'm really going to do is say that we're going to talk about this. I talked recently with Malad Ha about getting some boards made and distributed and out. We have to have a conversation as a group about the liability of distributing these items and how that changes when you go from distributing them as a charity for free and selling them. And while I'm not going to give anybody legal advice, I will give the advice that I got in terms of doing risk assessments. And I really want to recommend that we start doing some risk assessments on the devices that we're shipping. It helps us overall. It keeps people safer, and it helps us if there ever is a true liability lawsuit. So let's try to have that conversation over the next week or so. I hope everybody's healthy and happy and fun. Chris, I'm really glad you're back home and healthy. And I'll see you in about a month or so. But I guess that's about it. If anybody has questions, type them in the comments. I'll see them later. And I really appreciate it. I'll talk to you all later. Bye.